Next, we're asked to sketch a graph of y equals x squared, and I've got a graph here to represent the y equals x squared curve. Then you're asked, okay, if x equals 2, what's the corresponding y coordinate on the graph? And of course I've indicated x equals 2 here. What's the y coordinate of the point directly above x equals 2 on the x-axis? Well, y equals x squared. If the x coordinate is 2, then the y coordinate will be 2 squared, or 4. So we get the point 2, 4. Then, to the point where x equals 2 plus delta x. Here I've drawn it on the x-axis. Directly above that is a graph point where the x coordinate is 2 plus x. What's the y coordinate? Well, you square the x coordinate to get the y coordinate. The x coordinate is 2 plus x. The y coordinate has to be, and I say 2 plus x, it's 2 plus delta x. Okay, the x coordinate is 2 plus delta x, and the y coordinate is 2 plus delta x squared. So we have these 2 points on the graph. Now what's the slope between these points? Well, the slope is the rise divided by the run. We can sketch our usual triangle, and of course we want to always think in terms of that triangle to get the rise. So the rise goes from y equals 4 to y equals 2 plus delta x quantity squared. So the rise is this minus this, 2 plus delta x quantity squared minus 4. The run goes from 2 to 2 plus delta x. So the run is going to be 2 plus delta x minus 2. 2 plus delta x minus 2. Now we simplify this. We square the binomial. We don't say this is 4 plus delta x squared. I'm seeing a lot of that. We can't do that. This is a binomial. We have to square it by understanding that it means 2 plus delta x multiplied by 2 plus delta x, which is 2 times the quantity 2 plus delta x times the quantity 2 plus delta x. We could use a special formula, but we don't want to rely on that special formula all the time. We want to know how to square this. We want to know what it means, and we want to do that. So a little plug for being sure that we know what that means and how to do it. And when we do, and I'm not going to go through the details now, we've been through those details a number of times, we get 4 plus 4 delta x plus delta x squared by squaring this binomial. If you don't understand that, you really need to go back and write it out. 2 plus delta x times 2 plus delta x, and understand how we get this. Okay, in any case, now we're going to have this minus the 4. And in the denominator, I can write 2 plus delta x as delta x plus 2. The parentheses aren't really necessary, so I can remove them. And by changing the order of these, it's clear that we have x plus 2 minus 2, which is delta x plus 2 minus 2. I don't know why I'm not saying that delta, but I'm not. Which is just going to give us delta x. Then, when the 4's are subtracted, we have 4 delta x plus delta x squared. We can factor delta x out of this numerator. So we have delta x times the quantity 4 plus delta x divided by delta x. And now the delta x is divided by the delta x. That just gives us 1, leaving us the 4 plus delta x. I really don't want to see people canceling. I've seen too much bad canceling already from lots and lots of students in lots and lots of courses, including this one. People will cross out this delta x and cross out this delta x and think they're done, because you've learned to cross things out without understanding the rules, and the rules really come down to simplifying so that we divide a factor of the numerator by a factor of the denominator and get 1, leaving us whatever's left. So, I don't like cancellation. It's a habit people get into that they do wrong. So, just a little plug for doing the algebra. Okay. Now, next question is, what's the limiting value of this expression for the slope as delta x approaches 0? Now, why would I want delta x to approach 0? Well, let's go back to this series of secant lines. Okay, our delta x is from here to here. Then it's from here to here. Then from here to here, then from here to here, then from here to here, and we're going to let it shrink down, and as it shrinks down to 0, these secant lines will have slopes that approach that of the tangent line. So the tangent line is going to have a slope that's equal to the limiting value of the secant lines as the x interval, the delta x in this case, approaches 0. Now, this is exactly what we have here. We have a secant line. We've found the slope of this secant line. If we find the slope of secant lines for smaller and smaller delta x's is just the distance between 2 and 2 plus delta x. If we use tinier and tinier delta x's, we're going to get tinier and tinier segments, tinier and tinier secants, but they're going to approach the exact slope of the tangent line. So, what's the limit as delta x goes to 0 of the slope? Well, that's the limit as delta x goes to 0 of 4 plus delta x, which is the slope. And as delta x goes to 0, it should be pretty clear that 4 plus delta x is going to approach 4. So that the slope at this point, the slope of this tangent line of the y equals x squared graph at the x equals 2 point should be 4. Now we can do the same thing for x equals 3 and 3 plus delta x. So here's 3 and 3 plus delta x, and you're asked to simply go through the same process. Well, that's rather easily done. We have the point 3 squared on the graph, and the point 3 plus delta x, quantity 3 plus delta x squared. Okay, chalk's a little wide here. Might be a little hard to read that, but that's exactly what it is. So that the slope is going to be quantity 3 plus delta x squared minus 3 squared. That's the rise from this y coordinate to this one. And the run is going to be 3 plus delta x, the x coordinate here, minus 3. And that simplifies in a manner that's practically identical to what happened here. It's just that when we square this thing, we get 9 plus 6 delta x plus delta x squared. The 9 adds to the negative 9 and gives us 0, which doesn't have to be written down. You could say it cancels, but I really don't like to see that, except among a group who knows the restrictions on canceling and what it means. Okay, 9 minus 9 is 0, and 0 plus all this is just all this, so we end up with this. You don't need to use cancellation. You don't have to say it. Bad word. Okay, and now and in the denominator, the 3 and the minus 3 are going to give us 0, leaving us just delta x. Okay, so now we have 6 delta x plus delta x squared over delta x, and that reduces down to 6 plus delta x. And that should be very obvious. So then the limiting value as x goes to 0 of this slope is the limiting value of 6 plus delta x as delta x goes to 0, and that limit is just 6. For x equals 1, we could do the same thing. I'm not going to do it. I didn't do it in class. You can certainly do that. The limit is going to be 2 if you work through all the details. So that we have slope of 2 for the tangent line at x equals 1, 6 for the tangent line at x equals 3, 4 for the tangent line at x equals 2. Okay, we're asked to sketch a graph of that, of the slope versus x. Okay, so, well, when x equals 1, the slope is 2. When x equals 2, as we work through in detail, we find that the slope is 4. When x is 3, the slope is 6. 3 points here, they lie on what looks like a straight line. You can verify that it's a straight line by the fact that the slope from here to here is equal to the slope from here to here is equal to the slope from here to here. In every case, the slope is what? 2. You move over 1, you're going to go up 2. So the straight line has an equation where the slope is 2. We can also, from this graph, infer that despite the fact that I drew it through the origin, it really does go through the origin. You would expect me to miss. Okay? This graph really goes through the origin because the origin is a point on the graph. Because we go over 1 here and up 2, we end up at this point. Okay? Okay, so the origin, we just extrapolate the pattern backwards, and we do find the origin is a point on the graph, which means the y-intercept is 0, which means y equals mx plus b has b equals 0. Slope m is 2, so the slope of the graph is 2, and the straight line that we have here then has the equation slope, the y-coordinate being the slope. We don't want to call it y because we use y over here. Slope equals 2x. Now, that's actually a rule that we can take home. For any y equals x squared graph, the slope at the graph point with x-coordinate x is 2x. So whatever the x-coordinate is, the slope is double that at the point directly above.